Okay, so now we'll continue for the part for mutually exclusive events and addition law. So before I do that, I would like to do some recap or like some introduction of the knowledge of set notation with respect to the probability that we are going to learn together. So just a very brief introduction before we go into the multiplication law and addition law, as I think it will be helpful for you to understand the concept. Okay, so the first one, so when we talk about intersection of event A and B, right, is actually we talk about is the event. Okay, event, you can make these notes in your handout also, is actually the event that both A and B occur. Okay, I repeat again. So when we talk about the intersection of event A and B, is basically we talk about the event that both A and B occur. So the idea here is like A and B. Okay, so when we say that A and B has intersection, that means that normally we will use the notation of A intersect B. It's the same thing that we say that B intersect with A. Okay, so basically the idea is the same, whether A intersect with B or B intersect with A, or sometimes you will just write A and B. Okay, so how do we actually understand about this is like take an example. If I'm going to draw a set, so meaning that if I'm having a set notation like this, yeah, where this is A and this is B. Okay, so A intersect meaning that this circle is actually event of A, this circle is actually event of B. So event that actually both A and B occur will be the intersection part, meaning this is the intersection part. Is it okay? So this is when A and B intersect with each other. So let's try to see what happened if I have A and B that is in distinct circle but they are not touching each other. Yeah, so when you look at this, right, do they have the event or the probability that both A and B occur together? No, because they are having no intersection. So what is this mean? So this is basically meaning that your A and B, when A intersect with B, is actually a empty set. Empty set meaning that there's no element or there's no outcome that actually satisfy both A and B. So it's empty set, and normally sometimes we will write in this symbol also. In it's a noun meaning like it's a empty set also. Okay, so for this picture, right, we can say that the probability for A to intersect B is exactly 0 because they are not intersect with each other. So that's why the probability for both A and B to occur at the same time is 0. So this type of event, normally we call it as mutually exclusive. So later we'll be talking about this idea. Okay, so the second thing I want to say is about union of event A and B. Okay, so when we talk about union, we are talking about the event. Okay, we are talking about the event that either A happen, okay, that either A or B or both AB occur. You see the difference? So intersection means that we are talking about both A and B occur. So for union, we are talking about the words here is like the or. We are talking about either A happen or B happen or both AB happen. Okay, so if I were to draw this in if I were to write this in set notation, then it will be A union B. Or it's the same thing when I write B union A, and this one maybe sometimes we'll call it A or B also. Okay, so when you have this, right, how is the or B or A like is the same thing, or how is the set or the Venn diagram look like? So it will be something like this. So let's say if I have two, I draw the same thing like the above. that I have set A and set B. Okay, so this circle is the outcome for A, right? And this circle is the outcome for B. So when we talk about union of event A and B, meaning that we talk about the whole thing, the event that A happened. So this is the event that A happened. So, or the B happened. So this is the event where the B happened. Okay, and both AB occur is basically the inside one, so meaning the intersection like just now. So what you can realize here is like normally for this case, right, you will have something that is like very special here is like the probability of union. Okay, I try to draw the other one. This is the other one, which I have the same thing as above. Okay, what happened here is, let's say, this is the part that actually A consists of, and this is the part that is B consisted of. So when I want to find the probability of A union B, right, what happened is like, okay, you imagine this is like probability of A happen or B happen, right? Okay, so the probability of A happen, meaning that I already take this part, the whole part here. Okay, probability for A happen. Then after that, I will need to plus probability for B happen, correct? So that's why an event that A or B happen. So when I want to do this again, then I will need to plus this space. And what you can realize here is like I actually have the space that overlap in between here. So meaning that when I do again for the B part, what happened is I will repeat to add the middle part. So what happened here is when we want to find the probability of A union B, we need to minus probability for A intersect with B, because we are already adding it like 2 times. Like 1 time for this circle, the other time for this circle. So we are repeating adding the part in the intersection. Okay, so this is the one. But now let's see if this one is a mutually exclusive one, what happened? Because we say that the probability for A and B to intersect with each other is basically 0, right? So when you want to find the probability for A union B, what happened? It's like when you use PA, probability for A to happen, then plus probability to B to happen. So do you need to minus this part? No, because they have no intersection point. When I take probability of A, basically it's like here, probability for B is basically like here. So this is basically what the answer that I want for probability A or B to occur. Okay, so this is the general addition rule or addition law, but this one is like for mutually exclusive, because we say that the probability for A and B to intersect each other is like 0, so that's why we can eliminate this part. Okay, that's union. Okay, the third one is complement. So just now we already talked about this in the first video also, so I'm just going to quickly draw it. Okay, so for complement of A, right, basically we will write in the term of A prime. Okay, A prime. So how do we represent this in a Venn diagram? So if this is A, so where is my A prime? My A prime is basically, sorry, I try to do this. Okay, my A prime is basically what is outside of A. Okay, so you just remember complement is basically the event that A doesn't occur, or in other words, it's like the outcome that is not in A. So these are all complement. So what you can realize here is like the outside one is my sample space, right? So meaning I have A, the outcome in A, plus the outcome that is not in A is basically my sample space. So you still remember a complete probability we say is 1. So that's why the probability of A plus the probability of A prime is basically equals to, so you imagine S is like NS over NS, you are getting PS, so basically it's 1. So the probability for your sample space is happen, then of course for sample space is happen is like 1. So that's why when you plus it, it's equals to 1. So that's why the probability for A probability, or for A complement, or like A, for the probability that for the outcome that's not in A, or probability for A does not happen, is basically equals to 1 minus for the probability for A to happen. Okay, alright, so now look at your worksheet. I have written down this very easy question here, so maybe we use the knowledge that we have learned just now and try to solve this very short question before we go into the part for the mutually exclusive. Okay, so yeah, let's look at this. You have A, B, and you have C here. Okay, now let's try to write out everything for your event first. Okay, so my sample space, like the whole thing, I have 1, 2, 3, 4, 5, 6, 7. Okay, so after that, what is the event A? In the event A, I have 1, 2, 3. Okay, for event B, what do I have? I have 3, 4, 5, and 6. Okay, then for event C, I have actually 7. Okay, then now try to write down the probability for everything to happen. Okay, so probability for A to happen is basically 3 over 7 because I have 7 outcome in my sample space. So probability for event B to happen is 4 over 7. And the last one, probability for C to happen is basically 1 over 7. Okay, so now I want you to try to see like what is the complement first. Okay, so let's say we just try one for each, then for you to get the idea, that's it. Okay, so now let's say if I want to find what is the probability for the complement for B. Okay, so the first thing I want to find out what is the probability for the complement of B. So what will you do that? So you see you have B, right? Okay, what is your B prime? Your B prime is basically that what is the element that is not in B. So meaning what is the element that is not 3, 4, 5, and 6, meaning you have 1, 2, and 7. So the probability for B prime will be equals to 3 over 7. So what you can realize is I will get the same answer if I actually use 1 minus probability for B to happen. So which is 1 minus probability for B is 4 over 7, which gives me 3 over 7 also. Okay, so you can realize it's correct. Or when you look at the picture, you also can do this. So like, sorry, I should cancel this. Okay, so like for the probability for B, okay, so B prime is like anything that is not in B. So I have 1, 2, 7. So that's why 1, 2, 7. Okay, so now let's try to see the other one. Let's try to see if you have something that is like intersection. Okay, if I want to find the intersection between A and B. Okay, so you still remember what's intersection? Intersection meaning both A and B occur. So this is for A, this is for B. So the intersection is basically 3. So equals to 3. Okay, so the probability for A and B to both happen will be equals to, you will have only 1, so 1 over 7. Okay, alright, so now let's see. What if I want to find the intersection between A and C? So what you can realize, A is here and C is here. Or when you look at the number, right, you can realize that A intersect B, the common one is 3 and 3. So it's the same thing, the 3 in the middle. So now if A want to intersect with C, like 1, 2, 3 intersect with 7, 1, 2, 3 intersect with 7, do you have anything in common that A happen and C happen also? No. So that's why this is like an empty set. So we call A and C is basically a mutually exclusive. Okay, so mutually exclusive meaning that when A happen, you actually don't get something, don't get the event in C. So it's mutually exclusive. So that's why you will get the probability for A to intersect C is basically equals to 0. Okay, so let's talk about union. Okay, what if I want to find out, sorry, I will try to leave more space for you in your video. It seems like too small here. Okay. Alright, so let's say we talk about union here. So this is for intersect, this is for complement. Okay, so let's talk about union. Okay, so if I want to find A union B. Okay, so when you look at this, right, what is A union B? So meaning A or B happen. So A happen, you have 1, 2, 3. B happen, you have 3, 4, 5, 6. So when you want to write down the event, then it will be 1, 2, 3, 4, 5, 6. But what happens if without looking at this circle, then what you will realize is when you look at A happen and B happen, they have one common one. So when you write down, you are not going to write the 3 repeatedly. So you are just going to write it once. So the probability for A union B is basically equals to 1, 2, 3, 4, 5, 6, 6 over 7. Okay? But what you can realize here is like, let's say you remember just now what we talked about. Yeah. So I can use the exactly same thing like the addition law that we have done just now. Probability of A plus the probability for B, and I minus the probability for both A and B to happen, meaning the intersection part. So probability of A, I have 3 over 7, then plus probability for B, I have 4 over 7, and I minus the intersect just now, I have 1 over 7. So I will get the answer 6 over 7, which is exactly the same, like 6 over 7, 6 over 7. Okay, so if I want to find A union C, so when you look at this graph, or you look at A and C here, then you will realize A happen or C happen, it will be 1, 2, 3, and 7. So just now we already said it's mutually exclusive, so you can realize that the outcome that exists in A is not exist in C. So that's why you have 1, 2, 3, 7, and the probability for both A and C to happen, A or C happen, is like 4 over 7, which is exactly the same if you use the probability of A plus probability of C, which is probability of A 3 over 7 plus 1 over 7 will give you 4 over 7 also. Okay, is that alright? Yeah, I hope that you can understand this part. So below is like some notes for mutually exclusive, meaning the part that we are talking just now when A happen, then B cannot happen. So you just remember, two events A and B are mutually exclusive, or the other word for mutually exclusive will be disjoint. So we also say that AB is disjoint event when they cannot occur at the same time. So what are the example for mutually exclusive? Like when you toss a coin, the event that you get a head and the event that you get a tail, like you cannot get a head and a tail at the same time, like when we toast one time. So it's the same thing when a baby is born, it's either a boy or a girl. It cannot be like a boy and also a girl. So it's like a odd. So for a dice, when it's toast, it's either you get an odd number or you get number 6. You cannot get you cannot get number 6 when you get an odd number. Okay? So for the example below, it's like it's impossible that B happen when A happens. So all of these are mutually exclusive. So you just remember, for mutually exclusive, right, there is no intersection between A and B because they cannot occur at the same time. So that's why the probability for A intersect with B is basically 0. So I write down also 2 formula for you in your worksheet. Yeah, so you can see this and you can try to draw it beside. For the event that is mutually exclusive, the probability for A and B to occur is like basically the idea is that you have a set that A and B, they are not intersecting with each other. So for this case, you can basically do A union B. A or B to happen is basically probability for A to happen and plus B to happen. So for those is not mutually exclusive, meaning that they have intersection part, meaning when A happen, B can also happen. So for this case, then you will use probability A plus probability B, then minus the intersection point. So please bear in mind that in your syllabus that stated that this formula is actually not so they don't use it like so often. So that's why the thing that you should basically focus on is this one. But I also wish that you can understand this one because it's actually they are just related. The idea is that one is mutually exclusive and this one is not mutually exclusive. So if you can get the idea that they have, for mutually exclusive, meaning they have no intersection point, then you can get that this part is 0. So this is how you get to this formula. So again, try to understand everything because all this formula will not given in your exam. Okay, so now we will look at few examples together. Okay, so let's look at the question. So there are 6 examples here that we will go through together. So we'll look at the question that is like mutually exclusive first, then later on continue with the one that is not mutually exclusive. So the idea is just that using these two principles, so try to understand everything so you know how to do this instead of like memorize the formula. Okay, so a fair dice is tossed and the following events are obtained. So A is the event that get a even number, then B is odd number less than 5, then C is multiple of 3, and D is a prime number. So list out the sample space and for the following events and write down the respective probability. Okay, so let's try to do this. Okay, so list out the sample space. So let's try to write out the sample space first. Okay, the fair dice is tossed, so meaning that your sample space that you might get is like 1, 2, 3, 4, 5, or 6. Okay, so the event that obtain an even number. So again, you must please make sure that all your events will be depends on your sampling space. So even though I know like for 8, 10, 12, those are even number also, but that's not in your sample space and you can't do that. Okay, so event that obtain an even number, that it will be 2, 4, and 6. Okay, so event B that obtain an odd number that is less than 5. So meaning B, you have the number that is less than 5, basically is 1 and 3. Okay, so event that obtain a multiple of 3, so meaning that is 3 and 6. Okay, prime number, so remember 1 is not a prime number start with 2, so 2, 3, and 5. Okay, and write down the respective probability. Okay, so let's write down. So how many NS you have here? So number of sample space that you are having here is like 6. So probability for A to happen is basically 3 over 6, and then which gives you 1 over 2. I'm not going to write everything like that, and A over NS you should able to understand when you reach here. Okay, so after that, your probability for B to happen is at 2 over 6, which is 1 over 3. Probability for C to happen is at 2 over 6 also, which is 1 over 3. And then probability for D to happen is 3 over 6, which is 1 over 2. Okay, B, find the probability such that the number is even or odd less than 5. Okay, so when you do deal with this kind of question, then you might want to check and see whether it's mutually exclusive or not. Mutually exclusive meaning that they are not intersecting each other, or like event A happen, then event B cannot happen. So your event A is the number is even, so event B is like odd less than 5. So when you look at this, there's no number that can be even and odd less than 5 at the same time. Or when you look at the event that is like your A and odd less than 5 is like B, right? So you look at A and B, there's no intersection between your outcome. So that's why event A and event B are basically mutually exclusive. So when you say that they are mutually exclusive, right, when you want to find out the number is even or odd, meaning that you are finding probability for A or B. So you still remember or. So A or B to happen, we are talking about the union. So A union B. Okay, then this will be equals to, because they are mutually exclusive, they have no intersection. So it's basically probability for A to happen plus probability for B to happen, which is basically 1 over 2 plus 1 over 3. So which will give you 2, 6, so 5 over 6. Okay, so at the same time, if you don't want to do this, then what you can try to do is, of course, you can try to do A union B. Then you find out or write down, so what is the outcome that for the set A union B. So A union B, so basically what is inside is like 1, 2, 3, 4, and 6. Okay, so out of the sample space, then this is how you get probability A union B will be equals to 5 over 6 also, which you get the same answer. Okay, so for C, find the probability such that the number is a prime number or a multiple of 3. So a prime number and multiple of 3. So multiple of 3 you have 3, 6. And prime number you have 3, 2, 3, 5. And what you can realize here is the 3 repeat here. So if the 3 repeat here, meaning that for the event C and event D is not going to mutually exclusive, because when you want to find something that is prime number, then inside your prime number they might be the multiple of 3 also, which is 3. So your C and D are not mutually exclusive. So for a non-mutually exclusive one, when you want to find the union of the event, then what you need to do is you need to minus the intersection. So which what you can realize here is like your 3 and 3 is repeat here. Okay, so that's why probability for C or D to happen will be equals to probability of C plus probability of D, and then you need to minus probability for C intersect with D. Okay, so probability of C to happen is 3 and 6, so this is like 1 over 3, and for D to happen is 1 over 2, then you need to minus the probability for C to intersect D. So C intersect D is only 3, right? So 3 you only have 1, so that's why minus 1 over 6. Okay, or if you want to draw it out, then you can find out that if this is C, then this will be your D, and what is in between is either 3. So that's why you need to minus the 1 inside. Okay, so 1 over 3 plus 1 over 2 minus 1 over 6, you are getting 4 over 6, which will give you 2 over 3. Okay, so it's the same thing. If you don't want to do this, then what you can do is C union D will be equals to, so if you have 2, you have 2, 3, right? So you are not going to repeat that, so that's why 2, 3, 5, 6. So you are getting like probability C union D will be equals to 4 over 6, which is exactly the same answer like you get 2 over 3. Okay, so I hope that you can get this idea. This is like the simple one when you can see like every of your outcome. Then later you might have questions that you can't actually have all the outcome with you. Okay, so let's move on. Oops. Okay, so number 2. One digit is randomly selected from 1, 2, 3, 4, 5, 6, 7, 8, and 9. The 3 possible events are A, B, C. So show that the only pair of mutually exclusive event is A and B, and find probability for A union B. Okay, so how can you do that? Yeah, so the same thing, if you want to show that it's mutually exclusive, you still remember. So for mutually exclusive, they have no intersection point. So you need to show that in your outcome for set A and the outcome for set B, there is no intersection, meaning that there's no similar outcome that actually came out in both event. So what you need to do is, first one, you still need to write down all your outcome or the sample space for your event first. Okay, so A will be equals to a multiple of 3. So you have 3, 9, and 3, 6, and 9. Okay, then after that you have B, a factor of 8. So what is a factor of 8? You have 1, 2, 4, and 8. Okay, so a prime number is selected. So C, then you have 2, 3, 5, and 7. Okay, so these are all prime number. Okay, show that the only pair for mutually exclusive event is A and B. So you need to find out there's no intersection point between. So when you look at A intersect with B, right? So A intersect with B. Is there anything that they have in common? So 1, 2, 4, 8, and 3, 6, 9. So if you are going to draw in your Venn diagram, then it's going to be something look like this because they have no intersection point. So this is your A, this is your B. Basically, they have nothing, they intersect in between. So that's why it's an empty set, or you want to write like this also can. Okay, so it's an empty set. So the other one is because you need to show that it's the only pair, then you need to compare with other also. So let's see A intersect with C. Do you have things in common? Yeah, so 3, 6, 9, and 2, 3, 5, 7. So you can see 3 and 3 is the same. So the intersection point between event A and B is C. So it's the same thing. I'm going to compare the intersection point for B and C also, which will give me 2, and 2 is the same. So that's why it's 2. So you can realize that what you have here is like the number. You can write it again. So the event for A intersect with event of B is an empty set, and then what happened is number, so meaning that the number for A, B is basically 0, correct? So if you're having this, then meaning that the probability for A intersect with B is basically 0, so that's why it's mutually exclusive. Okay, so for the other one is not, because you actually have something like for A intersect C and A and B intersect C, the set is not an empty set, so that's why they are not mutually exclusive. So if you want to find out A union B, so as it is mutually exclusive already, meaning they have nothing that they intersect, so you can straight away probability A plus probability B. Okay, so which will give you, this one is 3/9 number that you have, and then plus with B that you have 4/9, that gives you 7/9. Okay, so B, you want to find probability for A union C. So you remember for A, C and B, C here, these are not mutually exclusive. So what you need to do is you need to minus off the one that actually intersect in between. So that's why P probability for A or C to be happen will equals to probability of A plus probability of B, then minus probability for A intersect with B. Okay, so A you have 3/9, then plus B you have 4/9, minus how many? You have only one, so meaning 1/9. So this will give you 7 minus 1, you get 6, so 6/9, which is 2/3. Okay, so let's move on for the next one, B union C. Okay, so for B union C, the same thing. So probability for B or C to happen will be equals to probability of B plus probability of C minus probability for B intersect with C. So equals to B is 4/9, C is 4/9 also. Then how many in common that you have? You have 1 also, so 1/9. So when you minus, then you'll get 7/9, which is your answer. Okay, so if you want to check, you can check and see like A, B union C, right? You have 1, 2, 4, 8, 3, 5, 7, which is 7/9. So this is how your number got correct. Okay, alright, number 3. A student attending a course estimate that his probability of obtaining the grade A, B, C, and D are 0.4, 3, 2, 1 respectively. What is the probability for the students get C or a better grade? Okay, so for this one, what you can C is like you identify first whether it's a mutually exclusive one. So for a student that attend a course, so can he or she has a grade like A or B like that? No. So no, it's like A and B together. So what is your grade for your A-level max? It's like A and B. So you cannot have something like this. So if you get an A, then it's an A. If you get an A, meaning that you cannot get B, C, D. So all this is actually a mutually exclusive, meaning that they cannot happen at the same time. So you cannot score a grade of A and B at the same time. It's either A, B, C, or D. Okay, so A, what is the probability that the students get C or a better grade? Okay, so get C or a better grade mean that the students can be getting a C or a B, sorry, it should be union, or a B or an A. Is it okay? Yeah, so I want to score C or a better grade. If you still remember the word or, that means that we will write it in union. So meaning C, he can get a C or get a B or get an A. So since this is mutually exclusive, meaning that I can use the probability of A plus probability of B and then plus probability of C. So what happened here is going to be 0.4 plus 0.3 and plus 0.2, which will give you the answer 0.9. Okay, so what is the probability that the student get at least a B? So at least a B, so meaning that the worst that he can get is a B. So meaning you will have probability at least a B, so meaning B or A. Okay, so probability for A plus probability of B, then it will be equals to 0.4 plus 0.3, which will give you 0.7. Okay, so for number A, right, if you want to, then you can try to do it the other way also. So the students get C or a better grade, right? It's the same if you want to do 1 minus probability that he actually get D. So you see 1 minus 0.9, you are getting 0.1, which is 1 minus 0.1 for probability for you to get a D, then you get 0.9 also, which is exactly the same thing. So depends on which way you want to go. Okay? Alright, so let's move on for number 4. Oops. Okay, number 4. In a survey, 50% of the participant owns a desktop, 60 owns a laptop, and 15 owns both. So what is the percentage of the participant owns neither a desktop nor a laptop? Okay, so try to write down everything like in the statistical language first, then that will be helpful for you to read the question. Okay. 50 of the participant owns a desktop, so meaning we say that the probability for the event D will be equals to 0.5. Then you straight away change the percentage to decimal because that's something that we are more familiar with. Okay, so meaning 0.5 of the participant actually own a desktop. So 60% of them own a laptop, so meaning that the probability for them to own a laptop is 60%, so 0.6. Okay, so 15% own both. Okay, so now you need to determine yourself. So own both, meaning that own a desktop or a laptop, or like owns a desktop and a laptop. Owns both, right? Meaning that I must have desktop and I also have laptop. So that's why this is going to be probability that D intersect with L. So meaning I have desktop, if I'm going to draw a circle, right? So meaning if this is desktop and this is laptop, the one that have both must be in the middle. So this is the intersection, not the union. Okay, so probability for me to have both desktop and laptop is 15%. Okay, so what is the percentage of the participant owns neither a desktop or a laptop? So you need to find out those that don't have both. Okay, so what you can try to do here is like, instead of finding those that do not have a desktop or a laptop, what you can try to do is you try to find out what is the union first. So the idea is that if I'm trying to draw everything here, then it will be like this. Okay, so this is a sample space. This is the circle for laptop, and this is the circle. This is the circle for desktop. This is for laptop. So I have this is 50%. This is 60%. And inside, in between is like 15%. I want to find out that those do not have. So meaning those that are outside. So meaning what happened here is basically what I want to get is I want to get the probability for like D union L. Okay, so you remember just now we said that this is like they have a desktop or a laptop. So what I want to find is like basically those that do not have both. So it's like the complement, the one that is outside is the space that I want to get. So those that do not have a desktop or a laptop, those that outside of the of my Venn diagram. Okay, so after that, then what I'm going to do is I can find out. So if you still remember for the complement part, so if we cannot straight away get to the answer, then we'll do 1 minus probability for D union L. So how can you find D union L? So you still remember the formula just now, right? So if we have DL and the intersect part, then we can find out the union. So P desktop union laptop, then it will be equals to the probability for desktop plus the probability of laptop, then minus the one that intersect. So meaning what I'm doing now is I'm taking the whole probability for the sample space, which is 1. Then I minus off the 2 circle here, which is D union L, to get what is outside. Okay, so equals to 1 minus, so PD is 0.5, PL 0.6, and then minus what is in common, 1.5. Okay, so when you get the answer, then you get 1.1 minus 0.15, and after that you get the answer at 0.95, and 1 minus 0.95 you get 0.05. So how many percent is basically 5%. Okay, I hope that you can understand it. Yeah, so what will be helpful is if you are feeling like a little bit confused here, then what you can try to do is you try to draw out the circle like this, then you will understand it better. Okay, number 5, the 100 students at a technical college must study at least one subject from pure maths, statistics, and mechanics. The number of the students that are studying is shown in this diagram. So P basically is pure maths and mechanics and statistics. So what does the number 17 mean? So this is the 17. So what you can realize here is let's say if I'm going to draw this, then 17 is like here. Then what is the event that happened in that particular section? Okay, so you can realize very obvious that this one is like the P intersect with S, correct? So 17, you can actually see that it's like part of pure maths and it's also part of statistics. But you can see this is something that eliminated outside the 17, so this is not. So this is like M is actually not in 17. So basically the 17 here refer to who? The students. Okay, so you can see like here and here is the intersection between P and S. So meaning that these students is actually taking both pure maths and statistics. Okay, so the students that take both pure maths and statistics. So what you can realize, did the 17 students take mechanics? No, because it's eliminated outside. It's like here, and then those who take the 3 subjects is actually here. That one is in M, in S, and in P, because you see this part is actually not in M. So take both pure maths and statistics, but not mechanics. Okay? Find the probability that a randomly selected student study pure maths or mechanics. So you see pure maths is here, mechanics is here. So you can see the intersection point is basically in between here. Is that okay? So this is pure maths, this is mechanics, this is N. But is that correct? Yeah, you want to find all. So meaning that you can find out the students that take pure maths or mechanics or both. So basically you are not only seeing this. If you are looking at this, meaning that you are saying that it's pure maths and mechanics. But now it's like pure maths or mechanics. So those who take pure maths without taking mechanics, can you consider them? Yes, because you say all. So that's why everyone in pure maths counted, everyone in mechanic also counted. But you can realize that the part that actually I shaded here is like the part that you repeated again. You repeat in your calculation. So that's why it's like consider these two are not mutually exclusive, because the students can take pure maths, can take mechanics. So both of them can be happen together. So they are not mutually exclusive. So that's why probability for you to get pure maths or mechanic, it will be equals to probability for pure maths plus probability for mechanic, and then you need to minus off the probability for those who take both subjects, because you are going to add them twice already. Okay, so equals to, so probability for PP, then it's like everyone inside here. So 33 plus 17 plus 32, so you will get 30, 50, and then 82. So 82 over 100 students, and then you plus with M, how many students that you have inside, 32 plus 7, which is 39. And then you need to minus off in between the 32. Okay, so after that, you continue to do it, then you will get the answer 89 over 100, which will give you 0.89. Okay? So it's totally fine also if you don't want to do probability, then you can find out the number first. So what you can try to do is 33 plus 17, then plus 32, and then plus 7. So you straight away find out, like, because when we say union, we are talking about the whole thing, right? So when I shade the whole thing, the number here actually I already like differentiated it into different region. So I can use 33 plus 17 plus 32 plus 7, then everything divided by 100, I should get the same thing also. Okay, So C, list the 3 subjects in ascending order of popularities. So you need to find out what is the number. So for this case, you do not actually need to find out the what is that called, your probability, because it's going to be the same if you find out how many students enroll in each of the course. So the number of students in Pure Maths is going to be 33 plus 17 plus 32, correct? So 33 plus 17 plus 32, which gives you 82. Okay, so the students that actually take mechanic, it will be 32 plus 7, so the circle here, so you'll get 39. So the number of the students that take statistic, it will be 17 plus 32 and plus 7, so which gives you 49 plus 7, which is 50, okay, no, 49, and then yeah, 56. Okay, so do I do anything wrong? Statistic 1, 2, 3, I left out something here, which is 11. Okay, so plus 11, then I'll get 67. Okay, so after I find out this, then I can list it out. So basically start from the less popular one, then you have mechanic, then after that you have statistic, then you have pure maths. Okay, you can write the full one if you have enough space in your paper. Okay, 6. Events x and y are such that probability of x equals to 0.5, probability of y 0.6, and the intersection point. So state giving a reason whether the event x and y are mutually exclusive. So when you look at this, how do you identify? So still remember, for mutually exclusive, when x happen, y cannot happen. So that's why they have no intersection point. So but this one you have intersection point 0.2, so that's why it's not mutually exclusive. Okay, so you just write down your answer, not mutually exclusive. And then why is that? Because the probability for x intersect y is actually 0.2, which is not 0. Okay, so if it's 0, then we say that it's mutually exclusive. So if in the case, then how do you want to find, if you want to find the union between x and y? So it will be x or y to be happen, then equals to probability of x plus probability of y, then minus probability of x intersect with y. So which is 0.5 plus 0.6, and then you minus 0.2, which gives you 0.9. Okay, that's it. So find the probability that x or y, but not both occur. Okay, so I hope you are not confused with the question. So this question is actually asking something like this. Okay, if this is x, this is y, and then this is 0.5, this is 0.6, then in the middle is like 0.2. So I only want to find the probability of x or y happen, but not both. So this part is the both part, so meaning I only want here and here. So I don't want this. So since that just now we already have x union y, the whole thing, that if we shaded the whole thing, then it's going to be like 0.9. So if I don't want for the probability that both happen, then meaning I will use 0.9 minus 0.2, which will give me 0.7. Okay, that's it. So meaning I minus the part that both happen, so I get 0.7. Okay, so that's the part. Then after that we are going to the third part of the lesson.